What if I told you that the universe screamed when it was born, and we can still hear the echo, not as sound, but as light? Ancient, cold, whispered light that carries a secret so profound, it rewrites everything you thought you knew about reality itself. Here is the part that should disturb you a little. Right now, as you sit there breathing, invisible radiation from the beginning of time is passing through your body. Every single second. It has been doing this since before the Earth existed, before the sun ignited, before any star in any galaxy switched on. This radiation is called the cosmic microwave background, or CMB, and scientists believe it is the most important thing ever discovered by human beings. Not because it is pretty, because it is proof. Proof of what? Proof that in the first fraction of a second after the Big Bang, the universe did something absolutely insane. Something that violates every normal intuition you have about how reality works. It expanded, not slowly, not gradually, but at a speed so incomprehensibly fast that distances grew by a factor of at least 10 to the power of 26. That is a 1 followed by 26 zeros, in roughly 10 to the power of negative 32 seconds. Less than a blink, less than a thought, less than anything you can possibly imagine. Scientists call this inflation. And here is the controversy. For decades, physicists argued about whether inflation actually happened or whether it was just a beautiful mathematical trick with no real evidence behind it. Some called it unfalsifiable, untestable, almost religious in its nature. Then came the maps. The Planck satellite, operated by the European Space Agency, spent years scanning the entire sky with precision instruments sensitive enough to detect temperature differences of 1 part in 100,000. What it found is haunting. The CMB, that ancient glow left over from 380,000 years after the Big Bang, is almost perfectly uniform. The temperature sits at about 2.725 degrees above absolute zero everywhere you look. Almost everywhere. Because when you zoom in, when you push the instruments to their limits, you see something that should not be there if inflation never happened. Tiny, faint, ghost-like temperature fluctuations. Variations so small they are measured in millionths of a degree. And yet they are not random. They follow a specific mathematical pattern, called the power spectrum, that matches almost exactly what inflation theory predicted decades before anyone had the technology to check. Stop for a second and let that sink in. Scientists sat down with equations in the 1980s, described a process that allegedly happened before any matter, any atoms, any light even existed, and they predicted a very specific signature that this process would leave behind. Then, years later, we built satellites and measured the actual sky. The match is extraordinary. The 2018 Planck data results showed that the spectral index of scalar perturbations, the technical term for how those temperature fluctuations are distributed across different scales, sits at 0.965. Inflation predicted it would be slightly less than 1. It is precisely where theory said it would be. But here is where it gets deeply strange and where the real debate ignites. Those temperature fluctuations in the CMB, those tiny hot and cold spots, they are believed to be quantum fluctuations. Subatomic scale uncertainties that existed before inflation then got stretched by the violent expansion of space itself to cosmological scales. Meaning the large structures of the universe today, the galaxy clusters, the cosmic web, the walls of galaxies stretching hundreds of millions of light years, all of it traces back to quantum foam from the very first instant of existence. The universe you live in is a magnified quantum accident. Inflation turned the microscopic into the magnificent. Now here is the part that makes even physicists uncomfortable. If inflation happened, it almost certainly did not stop uniformly everywhere. Most inflation models suggest it keeps going in different regions of space, even as it stops in others. This leads to what cosmologists call eternal inflation and the idea of a multiverse, a foam of bubble universes, each with potentially different physical laws. Our observable universe would be just one bubble. This is not science fiction. This is the natural mathematical consequence of the same theory that explains the CMB data so accurately. And that is what divides the scientific community. Because if other universes can never be observed or tested, do they belong to science at all? The BICEP experiments at the South Pole, including BICEP 3 and the Keck array, are currently hunting for something called primordial gravitational waves, specifically their imprint in the polarization of the CMB. If detected at the right strength, this would be the most direct evidence for inflation ever found. Results continue to be refined. The search is ongoing. The universe is still talking. We went from not knowing the CMB existed. It was accidentally discovered in 1965 by Arno Penzias and Robert Wilson, who thought they were detecting pigeon droppings interfering with their antenna, to mapping its finest details with satellites in orbit and instruments at the South Pole, and building an entire cosmological theory of our origins from light that has been traveling for 13.8 billion years. You are living in the most extraordinary era of cosmic discovery in human history. The technology is advancing. The data is getting sharper. The answers are getting closer. And the questions they raise are getting bigger and more beautiful than anyone imagined. So here's what I want you to sit with tonight. If quantum fluctuations from before time truly became the seeds of every galaxy, every star, every planet, every person, does that change how you see yourself in this universe? Drop your answer below. And if this kind of truth-chasing keeps your mind alive, follow for more, because we are just getting started.